Okay, you can see the slide, right? Everybody can see my slide?
Yes, sir.
Okay. So let's continue. Job slice. Sometimes we need to do job slice. Okay. Sometimes a system cannot meet all 3 frame size constraints simultaneously. Okay. Can often solve by partitioning a job with large execution time into slices or sub jobs with shorter execution time or deadline. Okay. By the way, sometimes we have also question related to the job slice. So sometimes we will ask you how you can solve the job slice, how you can overcome the miss deadline. So gives the effective of preempting the large job, so allow other jobs to run. Sometimes need to partition jobs into more slices than required by the frame size constraint to yield a visible schedule. For example, we have here 3 tasks: 4, 1, 5, 2, 7, and 25. So what do you think here? 4, 1, this is period, this is execution, correct? What about 5, 2, and 7? 5, 2, and 7. 5 represent what? 2 represent what? And 7 represent what?
5 is period, 2 is
Okay.
execution, and 7 is deadline, sir.
Deadline, correct. So here cannot satisfy constraint equation 1. Why? Because following the execution here, 1, 2, 5, the maximum is 5. But follow the last execution, the frame size should be equal 4 or, okay, should be less than or equal 4. We can solve it by splitting task 3, because as you see here, task 3, the execution time is very large. We splitting it into 3 jobs, okay, like 20 and 1, 20 and 3, 20 and 1. So total execution will be 5, but we divide it into 3 jobs or 3 sub jobs. So other possible split exist based on the application domain knowledge. The result can be scheduled with frame size equal to 4. Okay. What do you think? Can we split task 3 into 2 subjobs instead of 3 subjobs? Because as you see here in this image, in the first line, we divide it into 4 jobs. See here, task 3, 1, task 3, 1, 2, task 3, 3, and task 3, 4. Here, we divide it into 3 jobs. So 4 job, 3 job. What do you think? We can split it into 2 jobs that we can satisfy all the 3 constraints. Anybody can answer? Can we split task 3 into 2 jobs only? Yes, can. Let's say 20 and 2, 20 and 3. Still can satisfy frame size equal to 4. Okay. Okay. Building a structured cycle schedule. To construct a cycle schedule, we need to make 3 kinds of design decisions. Choose a frame size based on the constraints, partition job into slices, and place slices in frames. These decisions cannot be taken independently. Okay. Ideally, want as few slices as possible, but may be forced to use more to get visible schedule. Implementation, a cyclic executive. Modify previous table, drive cyclic scheduler to be frame based schedule all type of jobs in a multi-threaded system. Table that drives the scheduler has F entire, where F equal to H divided by F. Each corresponding entry, LK, which is current block, list the names of the job slices that are scheduled to execute in frame K, call it a scheduling block. Each job slice implemented by a procedure to be called enter. Cycle executed by the clock interrupt that signals the start of a frame. Determines the appropriate scheduling block for this frame. Executes the jobs in the scheduling block in order, and start job at head of the aperiodic job queue running for a reminder of frame. Less overhead than pure table driven cyclic scheduler, since only interrupted on frame boundaries rather than on each job. Scheduling a periodic job. As I told you, we have periodic job and a periodic job. In simple word, we can say the periodic job is the main tasks, okay, is the main target or the main job that we need to execute. While a periodic is like extra jobs or additional job that we need to execute it. So thus far, a periodic job are scheduled in the background. Okay, later we will understand what does the mean of background in the next chapter. This is the first type of the scheduling that we will deal with. So background, after all jobs with hard deadline scheduled in each frame have completed. Delays execution of a periodic job in preference to periodic job. That means we will delay execute a periodic job to give a priority to the periodic job first, since periodic job, as I explained just now, it's the main target or the main jobs that we need to execute, while a periodic is like extra job or additional jobs. However, note that there is often no advantage to completing a hard real-time job early, and since an aperiodic job is released due to an event, the sooner such a job completes, the more responsive the system. Okay, so here we minimizing response time for a periodic job is typically a design goal of real-time scheduler. So the main target for us or for schedulers is to find the minimum response time. Okay. Scheduling a periodic job, slack stealing. Now I will show you how we can schedule the timing diagram without slack stealing, okay, and with slack stealing. Periodic job scheduled in frames that end before their deadline. There may be some slack time in the frame after the periodic job completes. Okay, since we know the execution time of periodic jobs can move, okay, this is the most important, pay attention please, can move the slack time to the start of the frame, running the periodic jobs just in time to meet their deadline. You will understand when I show you the example, this point. This point means, first of all, we must execute periodic job. Once we meet slack time, we can execute the aperiodic job. But in slack stealing scheduling, okay, we can move the slack time to the start of the frame, to the beginning, okay, to run in the aperiodic job if, this is the important condition, if periodic jobs can meet their deadline. Okay, so execute aperiodic jobs in the slack time ahead of periodic job. Okay, execute a periodic job in the slack time. Usually we execute periodic job, the priority given to periodic jobs, not a periodic. But in the slack stealing, execute a periodic jobs in the slack time ahead of periodic job. That means the priority will be given to a periodic jobs, okay, not periodic jobs. Okay, so we can shorten all the explanation previously that normally, okay, in the hard time, we execute periodic job first. Then when we meet slack time, student means a whole. See, like here, this is a whole, this is a whole, this is a whole, okay? So in the hard time, we execute periodic job first. Once we meet slack time, we can execute a periodic. That's without slack stealing. With the slack stealing, we give a priority to a periodic job. Okay? In case, okay, we need to focus. In case the periodic job will not miss their deadline. So the cyclic executive keeps track of the slack left in each frame as the periodic job executes. Preempt them to start the periodic job when there is no more slack. As long as there is slack remaining in a frame, the cyclic executive return to examine a periodic job queue after each slice completes. Reduce response time for a periodic jobs, but required accurate time. That's mean the response time, okay, the response time of the slack stealing scheduling, it's much better than the response time without slack stealing. Okay. Okay, we'll go to next. Let's take this example. We have 3 periodic tasks. Task 1, 4 and 1. Task 2, 5 and 2. And task 3, 8, 10 and 1. Okay. Who can tell me 8 represent what? 10 represent what? 1 represent what? Anybody? Anybody can participate, please? We know here.
Sir,
Yes.
8 is the period,
Okay.
10 is the execution,
Okay.
and 1 is the deadline.
Who's that? Your name?
Me, Tommy.
Tommy. Everybody agree with Tommy? Tommy said 8 period, 10 execution time, 1 what? Deadline?
Yeah, deadline.
Deadline. Everybody agree with Tommy?
But the execution time should be less, right, sir?
Exactly. Who's that? Yalan?
Yes.
Thank you, Yalan. I already said this is most important to know all the time. All the time. The execution time always less than period. Okay? Sometimes deadline more than period, sometimes deadline less than period. But execution time always and forever is less than period. So if 8 is period, how can 10 become execution, Tommy? So, Yalan, do you know what is the correct substitute here? Or
8 is
Each-
period, 10 is deadline, and 1 is execution time.
execution time, 8 period, 10 deadline, 1 execution time. Everybody agree with Yalan? Everybody agree with Yalan? Any additional opinion? Everybody agree. By the way, Yalan, I'm surprised you make a mistake here because you especially you asked me about this. I told you if we have 2 value, okay, yeah, we know the period is more than the bigger number is period, the lesser number is execution. But if we have 3 number or 4 number, what we should to do, Yalan? What was my answer to you? If we have more than 2 value,
We should
What we should-
use the PCD follow.
follow the sequence, correct? Is
Yes.
it correct sequence here?
No.
No. What is the sequence given in the previous slides?
PCD. Period, execution, deadline.
Here. See?
Yes.
First the phase, second period, then execution, then deadline.
Yes.
Here. This is period, execution, deadline.
Yes.
What in this case? So always deadline at the end. Deadline at the end. Is this deadline? So what is the correct answer? Each number represent what? Yalan. 8 represent what? You said period, yeah?
Yeah.
And this is deadline. And this is
Yes.
execution. Deadline should be at the end. So your answer wrong.
Okay.
So what's the correct answer? Look. What is the first value should be? Phase. So 8 will be phase. 8 will be phase. 10 will be period. And 1 will be execution. There is no deadline. Deadline equal to 10. So phase. Look to the task number 3. Where's task number 3? See task number 3? We couldn't. Here we have a hole. Why we didn't execute task number 3? Look here. Here we have a hole. We execute task 1, task 2, and we skip task 3. Why? Because the phase of task 3, the start point, will start from 8. 5, 6, 7, 8 here. See? So this is the phase. Okay, students? Understand now how to differentiate?
Understand, sir.
Okay. So we have 3 period and we have 3 aperiodic task. A1, 4, and 1.5. So for aperiodic is different. A4 represent the release time. Represent the release time. Okay? 1.5 execution time. So a periodic job 1 release at 4. Okay, release at 4 as you see here. Release at 4. And we need to execute 1.5 units. Here we execute 1 unit, and here we execute the next half unit. So maximum 1.5. A periodic 2 release at 9.5. 9.5 here. 9.5. But we cannot execute it because there is no slack time. We execute it, only we have slack time. And we need to execute half unit. Half unit. A periodic 3 release at 10.10. 10.10. And execute 2 unit. Here 1 unit and here 1 unit. Okay? Who can tell me where is the scheduling with slack stealing and where is the scheduling without slack stealing? Who can tell me which one? You see here we have 2 types of scheduling. The first one and the second one. Which one with slack stealing, with which one without slack stealing? Anybody? Anyone? Just now I said the previous slide here. We can execute the aperiodic. First one. Nick Razin, open your mic, Nick. Can you open your mic? Razin, Nick Razin.
Yes, sir.
So why you typing? Why you typing? Answer, please. You shy to participate?
Hello, sir.
Why you are typing since your mic working?
Sorry, sir.
Yeah, yeah. So which one is Slack stealing? Which one is
First
without Slack?
First one without Slack stealing. The second one is with Slack stealing.
Yeah, correct. Excellent. So the first one, as you see, without Slack stealing, we follow the hard time. That's mean we execute a periodic only in the frame, only in the Slack's time, only in the hole. So Nick Razin, look here. We execute A1 in this hole, correct? We execute A1 also in this hole. This is, we have Slack time. We execute it. Here we also have Slack time. We execute it. Why we didn't execute it here? Between 1, 2, 3, between 3 to 4. Why we didn't execute the periodic jobs? Who can tell me why? Since the rule of without Slack stealing, that we can execute a periodic job only in the hole, only in the Slack time. But why we didn't execute it here? Anybody? Anybody can tell me why we didn't execute a periodic?
Doctor, is it because the pay starts at 4?
Because start at 4. Excellent, Rojin Raj. Excellent. Yes, because the release time of A1 is at 4. So since it released at 4, how we can execute it before 4? So yes, because the release time at 4. But we cannot execute a periodic job at 4 since we have the priority for the periodic job. The priority given for periodic job. So as you see, this is without Slack stealing. This is with Slack stealing. The different, we execute a period. The priority is too simple. The difference between them, the priority without Slack stealing given to what? To periodics job, while in Slack stealing, the priority given to a periodic job. Once we reach the release time, we execute a periodic, as you see here. Here we postponed it. Here release, we execute it. Here release, we execute it. Here we postponed A2, we postponed A3. Okay, that's the difference. And definitely the response time of Slack stealing scheduling, the response time much better than without Slack stealing, because since early response it, we get better response time. Okay. Okay, this is also one more example showing the difference between the jobs. Here, hard real time, the normal should be executed like that. Okay. A periodic job given 4 to 5.5. Okay, 1.5. Here we should execute the periodic. Here we should execute the periodic. And as you see, without Slack stealing, A1 was postponed to 7 to 8, then 7 to here 8, 9, 10 to 10.5, and also a periodic 2 was postponed, and A3 also need to execute 2 units, also was interrupted. While with Slack stealing, the priority given to a periodic jobs. Once release, okay, we will execute it. Because, as I say here, the cyclic executive kept track of the Slack left in each frame as the periodic job executed. Preempt them to start the periodic jobs when there is no more Slack. Okay. So here, the Slack actually here, the Slack time here, but we move the slack time to the beginning of the frame. See here the slack. We move it to the beginning to execute the aperiodic. As I say just now, since we know the execution time of periodic jobs, can move the slack time to the start of the frame, running the periodic job just in time to meet their deadline. Okay, and that's what we did here. We move the slack to the beginning, and we still can execute task 1 and task 3 without miss deadline. If there is any miss deadline, no, we must give the priority to the periodic. Okay, so here look to the without slack stealing, the response time. How to find the response time? It's too simple. We deduct the release time from the completing time. Okay, so 10.5 minus 4, we get 6.5. 11 minus 9.5, we get 1.5. And 60 minus 10.5, we get 5.5. This is the response time without slack stealing. And as you see, the response time with slack stealing is much better. 6.5 become 4.5, 1.5 become half, and 5.5 become 2.5. Okay. Okay, let me give you example. One more example. Okay, look to the schedule with slack stealing. Okay, since the priority given to the aperiodic, correct? And we need to execute how many units of aperiodic 1? How many units we need to execute of aperiodic 1?
1.5.
1.5. Why we execute only 1 unit, not 1.5? Why we execute 1 unit, not 1.5? Who can tell me?
It only can fit 1 unit, sir.
Why? Because the frame size is 4. Okay, 0 to 4, 4 to 8, 8 to 12, 12 to 16, and so on. So if we execute here 1.5 from aperiodic 1, if we execute 1.5 as given here, task 1 or task 3 will exceed a deadline. As you see here, exactly fit for aperiodic task 1 and task 3. So we must focus on that to not let the periodic job to exceed their deadline. Let me give you the example and you will more understand now. Okay, so let's take this example. We have task 1. Two, 3.5 and 1.5. Okay, and we have task 2. Six 0.5, 0.5. Okay, we have 2. How we can call this tasks? This is periodic job or periodic task. And we have also we have 2 periodic jobs, and we have also 2 aperiodic job. First aperiodic 2.8. Yeah. And A2 5.5 2.5. So who can tell me, please, this value represent what? 2 represent what? 3.5 represent what? And 1.5 represent what? Yalan?
So 2 is phase, 3.5 is period, and 1.5 is execution time.
Yes, excellent. Here,
6.5 is period, and 0.5 is deadline.
deadline,
No, sorry, execution time.
execution time. Deadline actually equal to period, okay?
Yes.
Okay, what about A1?
2.8 is release time, and 1.7 is unit of
Execution.
execution.
How many units we need to execute?
Yeah.
This is the same, okay? So here we have 2 periodics and we have 2 aperiodics. Let draw the timing diagram following the normal one without slack stealing. Please, student, follow my way how to draw timing diagram. Exactly how I'm doing, you do. If you follow my way, it will be easier for the next coming scheduling. This is just fundamental, you know. I will. This is just beginning. Next, it's more critical and more you need to focus and pay attention and differentiate how to differentiate each task from all the periodics giving and each aperiodic from the all aperiodic. Sometimes I give you 4 periodics and 4 aperiodic. So to differentiate between each one of them, please follow my way. So this is, we start the timing diagram as normal. This is from 0. Okay. One, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so the first step, we will indicate each task from the periodic with different color. Okay, we have task 2. Let's use the same color, blue color for task 1. We have task 1. Task 1, some student will draw it like that. This is for task 1, but actually the start point for task 1 starting from 2, correct? So that's wrong to start from 0 since the phase, our phase at 2. So we will start from 2 to draw the timing diagram of task 1. So this is for task 1, okay, using blue color. Here the period 3.5. So from 2 we count 3.5. 1 unit, 2 unit, 3 unit, and half. So this is will be first interval, then half, 1, 2, 3. This is second interval, 1, 2, 3, and half, and so on. Okay, half, 1, 2, 3. Oops. Okay, that's for task 1. Done. We go to next task, which is task 2. 2. Let's choose any different color. Okay. Task 2 starting from 0. So as normal, task 2, and we indicate or defined the period 6.5. So 6.5, this is first interval. Next will be at 13. Okay, and so on. Okay. Now we have defined or draw the period of periodic tasks. Okay. Now we need to add a periodic. How to add a periodic here? Like that. We use usually for a periodic we choose a red color. First, a periodic release at 2.8, correct? So 2.8. That's mean here 2.8. This is first a periodic. For first a periodic release at 2.8. How many units we need to execute? 1.7. 1.7. Okay. Next, a periodic release at 5.5. 5.5, which is here. This is A2. Release at 5.5. How many units we need to execute? 2.5. Okay. And this is without slack stealing. Okay. So let's start how to execute the periodic and a periodic without slack stealing. Okay. First of all, we start from 0. We start from 0. At 0 unit, how many tasks of all the periodic and aperiodic, how many tasks ready to be executed? Anyone can tell me? We have periodics, 2 periodics, and 2 aperiodics. How many tasks of all that 4 tasks ready to be executed from unit 0? How many? How many units? Sorry, how many tasks ready to be executed from 0? Student, this is too simple. This is really just fundamental. How many tasks can be executed here?
2, sir.
2, which is?
A1 and task 1.
A1 and task 1.
Yeah.
Look to the task 1. Task 1 start point at 2. If start
sorry,
at
sir,
2,
task 2.
how we can task 2?
Yeah.
So task 2 and A1, yeah? And A1?
This is task 2 and A1.
Your name, please?
Nik Razin.
Nik Razin. Task 2, agree with you. A1, I'm not agree with you. 2.5 represent what? Release time, correct? So since A1 release at 2.8, how we can execute it at 0? How we can execute A1 at 0? If it will release only at 2.5, A1 will arrive at this destination, how we can execute it earlier? So do you understand your mistake, Nick Razin?
Yes, sir.
Yeah, so A2 also release at 5.5. Also, we cannot execute it. The phase of task 1 at 2. Also, we cannot execute it. So from 0, we have only one task ready to be executed, which is task 2. Task 2, how many units we need to execute? Half unit. So we execute that half unit following the same color. Okay? Following the same color. From 0 until 0.5, we execute task 2. Done. What we can execute from 0.5? Nothing. From 1, nothing also. Until 2. Why until 2? Because at 2, the start point of task 1. The start point of task 1. So at 2, we can execute task 1. Okay? Since the start point at 2. This is without slack stealing, okay? So we use the same color. From 2, we can execute task 1. How many units we need to execute? How many we need to execute of task 1?
1.5.
1.5, correct. 1.5 starting from 2. So here, 1 unit and half. This is for task 1. See, a periodic 1 release at 2.8, but a periodic cannot preempt a periodic since this type is without slack stealing. That's mean the priority given to the period. The priority given to the period. So a periodic cannot preempt periodic since the priority for periodic. But in the slack stealing, at this point, 2.8 a periodic will preempt periodic. A periodic A1 will preempt T1. Okay, since on in the slack stealing type, okay, the slack stealing scheduling, the priority given to a periodic, not the priority. Okay, but this is without slack stealing. So here we execute task 1 totally all the given execution time 1.5. Okay, then what we can execute from 3.5? 3.5, what we can execute here? Who can tell me?
A1.
A1. Is A1 release? Yes, release at 2.8. So we can execute A1. How many units we can execute of A1?
1.7.
1.7. Okay. Let's use same color. Okay. So from 3.5, half unit, 1 unit, so 1.5. Okay. The total 1.7. So extra plus 0.2. So around this area. A1. Okay. This is for A1. What we can execute after that? This is 5 point. This is 5.2. So from unit 5.2, what we can execute here? What we can execute here? Anybody can tell me what we can execute from 5.2 until 5.5? Nothing, exactly. Look to the task 1. Task 1, we need to execute 1.5, each 3.5 unit. So from 2 to 5.5, so this first interval of task 1. Next, next, next. So did we execute the 0.5 in the first interval? Yes, here we executed. So task 1 has terminated its task in the first interval. So nothing to execute. Done. We go to check task 2. Task 2, this is the task 2 interval from 0 until here, first. This is second, and so on. Is task 2 has executed their execution time? Yes, we already executed. In this period, we execute the first half unit. So task 2 also has terminated its task in the first interval. Done. Okay. What next? What else? A1. A1 also. We execute 1.7 already here. What the left? Left A2. Can execute A2 here? Cannot, because A2 release at 5.5 and we are at 5.2. So nothing. This will be our idle. Okay, nothing to execute. Okay, at 5.5, at 5.5 here, what we can execute, how many tasks ready to be executed at this unit 5.5? How many tasks ready to be executed at this unit 5.5? Who can tell me?
T1 and A2.
T1 and A2, correct. T1 and A2. This and this. The priority without slack stealing given to what? To periodic or aperiodic? And this type of scheduling, the priority given to periodics or aperiodics?
Periodic.
Periodic, correct. So the priority given to task 1. So we execute task 1. Okay. How many units? 1.5. 1.5. So we choose the color of task 1 and we execute task 1. This is half unit and this is 1 unit. Task 1. So now we can execute A2 from 7. Can we execute A2? Can we execute A2?
Answer.
Can, yeah?
Yeah.
If you check here, task 2 release at 6.5. So that's mean we in this point we have two options: execute task 2 and A2, but the priority given to task 2. So means we cannot execute A2. A2 still postponing till we find slack time. We find slack time. At the whole, we can execute the aperiodic jobs. Okay, since we have the priority given to the periodic, we execute only periodic first. Then we execute the aperiodic when we have a whole. So since task 2 release at 6.5, okay, we execute task 2. How many unit? Half unit. That means 7 until 7.5. This is task 2 until 7.5. Okay. After that, we cannot, from 7.5, we cannot execute task 1 and task 2 because task 1 and task 2 have terminated their task. In this case, once we have slack time, we execute aperiodic 2. Okay? Now we can execute aperiodic 2. How many units we need to execute of aperiodic 2?
2.5.
2.5. So can we execute the 2.5 all the 2.5 or half or some of them? Who can tell me? This is half unit, 1 unit.
Cannot all, sir, because
Cannot all.
will be exceed the deadline.
Exactly. So we can execute until 9 only, because at 9 there's new interval of task 1. So we can execute A2 only from 7.5 until 9. So we execute 1.5 only. The remain will be 1 unit. At 9, the start point or the new interval start of task 1. So we need to execute task 1. How many unit? 1.5. 1.5. Task 1. Okay. Next, what we can we execute task 2? Since the priority given to the periodic, can we execute task 2?
No,
No. Why?
because the execution at 13.
Exactly, because the interval of task 2, it's from 6.5 until 13. And we need to execute only 0.5, which already done. So task 2 has terminated its task. So no need to execute it. So in this case, we execute the remain of A2. The remain of A2, which is 1 unit from 10.5 until 11.5. A2. Once we complete a periodic, just stop and find the response time of each aperiodic. The response time of aperiodic 1, we find the complete time when we complete A1 and minus release time. So the complete time of A1 at 5.2, correct? 5.2 minus release time of A1 2.8. 2.8. Sorry, 2. Yes, 2.8. Equal 5.2 minus 2.8. How much?
2.4, sir.
2.4. This is the response time of aperiodic 1. Response time of aperiodic 2. Complete time of aperiodic 2, which is at 11.5, minus release time of A2. Release time at 5.5. Equal 6. Okay. Okay, I give you 2-3 minutes break. Just write down your notes here. Then I will show you how to draw the timing diagram using Slack stealing scheduling. Okay. Okay, do you need more time? Do you need more time, student, to write your notes? Please answer. You need more time, or I start with the slack stealing scheduling?
2 minutes, sir.
Yeah, sure. So done.
Yes, sir.
Okay, so now we go. I'm going to show you how to draw the timing diagram using the slack stealing scheduling. Yeah, same example, but the first one without slack stealing, and the next with slack stealing. So we draw the same timing diagram. From 0, 1, 2, 3. Okay. Task 2. Sorry, task 1 starting from 2. So we'll start from here. Task 1. The period. $6.5. 6.5. So from 2, sorry, the period is 3.5. The period 3.5, we count from 2. So 1, 2, 3 and half. This is the first interval. Then half, 1, 2, 3. Next, 1, 2, 3 and half. Half, 1, 2, 3. Okay, this is the task 1. Task 2, start from 0. The period 6.5. So 6.5. Next 6.5 will be at 13. Okay. A periodic. First, a periodic release at 2.8. 2.8. And need to execute 1.7. Okay, first a periodic. Second, the periodic release at 5.5. Need to execute 2.5. So 5.5. Need to execute 2.5. This is A2. And this is A1. Okay. So now, very clear. As I told you, choose different color for each task. Now we need to execute them using slack stealing. Okay. Okay. So first of all, as I told you, starting from 0, how many units ready to be executed? We have only task 2. Okay, since task 2, so task 1 starting at 2, A1 starting at 2.5, A2 starting 5.5. So we have only one task ready to be executed from 0, which is task 2, only half unit. Okay, then it will be suspended until 2. Okay, at 2, task 1 start point will start at 2. Then we can execute task 1 following the same color. Task 1, how many units we need to execute of task 1? We need to execute 1.5, correct? 1.5. Can we execute the 1.5? This will be first one, and this is the half. Is that correct what I'm doing? Am I correct? We need to execute 1.5 unit. We need to execute 1.5 unit of task 1. Is that correct? We can execute the 1.5 here?
Yes, sir. Yes, sir.
Yes. That's Tommy.
Yes.
Everybody agree with Tommy? Everybody agree with Tommy? No. Who's that?
Nick.
Your name, Nick?
Nick Razin.
Yeah, Nick. Your opinion, please. Why you disagree?
Because for slack stealing, we need to prioritize the periodic first, right?
Exactly. Exactly. Thank you, Nick. So the difference between with slack stealing and without slack stealing, the priority when we have this type of scheduling without slack stealing, the priority given to the periodic, But with slack stealing, the priority will given to a periodic, and as you see here, a periodic job release at 2.8. Okay. Here 2.8. So since the priority given to a periodic will preempt periodic. Okay. So this is periodic. Okay, task 1, task 2, and this is aperiodic. So the priority given to this, to the periodic, once we're using without slack stealing. But we would use slack stealing, the given priority will be to aperiodic. So since aperiodic release at 2.8, it will preempt task 1. So task 1, as you see here, we execute task 1 from 2. We keep moving until 2.8 and stop. That's mean here of task 1, we execute only 0.8. Only 0.8. The remain will be 0.7. Okay? We must to focus on that. The remain will be 0.7. This 0.7 should be executed in the first interval. Otherwise will be miss deadline. Okay, that's what I mentioned just now in the slide. I see. Since we know the execution time of periodic job can move the slack time to the start of the frame. That's what we did just now. So as I said, a periodic we executed in the slack time, but here in this case, we move the slack time from the end to the beginning to execute a periodic. Okay, in case there is no missed deadline, we need to focus that there is no missed deadline. Otherwise, we continue executing the periodic. So here, since we release to the periodic here, a periodic, how many units we need to execute? 1.7. So we execute that 1.7. Here, 2.8 until 3. Okay, until 3. From 3 until 4. How many units? 1.2, correct? Here, 0.2 plus 1, 1.2, and 0.5 more. Half unit more will be until 4.5. Okay, 4.5. This is a periodic 1. So done with a periodic 1. Okay, the remain of task 1. How many? 0.7. Can we execute 0.7 in this one? Here, how many unit we have? Half plus half, 1 unit. But we will need to execute only 0.7. That's mean there will be no missed deadline. Everything okay? There is no issue with the missed deadline. Okay? That's mean all what we are doing now is correct. 0.7 from 4.5 until 5. Only half unit, and plus 0.2. This is task 1. Okay? After 5, this is 5.2. 5.2, we cannot execute anything because it will be our idle. Okay? So at 5.5, how many tasks we can execute? 5.5. How many tasks we can execute? as you see, task 1 and a periodic. Task 1 and a periodic. At 5.5, we can execute 2 tasks, which is task 1, new interval, and A2 release at 5.5. So since we have 2, the priority given to what? To which task? Task 1 or A2? Task 1 or A2?
A2, sir.
A2, because this is slack stealing. Slack stealing, the priority given to the aperiodic. Okay? So slack stealing, the priority given to the aperiodic. How many units we need to execute? How many units we need to execute? Please, student, pay attention now. This is the most target to show you this example at this point. Pay attention now, okay? So how many units we need to execute of A2?
2.5.
2.5. Okay, let's start. Half unit. 1, 2. Correct? So A2. Okay. Is there will be missed deadline? We should execute task 1. Okay. Look to the task 2. Task 2 also need to be executed. But task 2, how many units we need to execute?
0.5.
0.5. So, and we have the whole this time, look, from 6.5 until 13. So definitely there will be no missed deadline. The critical issue here with task 1, how many units we need to execute of task 1?
1.5.
1.5. Okay. Can we execute the 1.5 here? Look.
No.
No. It will be here. We have only 1 unit. It will be what? Missed deadline. So what we are doing, it's wrong. What we will do in this case, okay, to avoid or to avoid any missed deadline, in this case, we will execute first. First, we will execute task 1 from the end, because to prevent the missed deadline, we execute it from the end. That's mean 9 to 8, 1 unit, and we have more half unit until 7.5. Correct? 7.5. This is for task 1. And in this way, we can execute the aperiodic job. I repeat what I say in the slide. Since we know the execution time of periodic jobs, which is task 1, can move the slack time to the start of the frame, running the periodic job just in time to meet their deadline. Okay, that's what we did, to meet their deadline. So here we execute the aperiodic. Let's count how many. Half unit, 1 unit, so 1.5 plus half unit. So how many units we execute here of A2?
Only 2.
Only 2 units, correct. The remaining will be
0.5.
0.5. Next, starting from 9, what we can execute at this. Tell me how many tasks ready to be executed at unit 9. Who can answer this question, please? How many tasks of periodics and aperiodics ready to be executed at this unit?
T1, T2,
T1, T2,
A2.
A2. Excellent. The priority given to what?
Aperiodic.
Aperiodic, correct. So we execute aperiodic first. In case with important condition, if there is no missed deadline. How many we need to execute of aperiodic? Of only half. So as you see, we can execute half, and we still have a huge time to execute T1 and T2. Agree? Let's confirm. So we execute that half unit from 9 until 9.5. This is A2. (9.5) done. Then task 1, how many unit of task 1? 1.5, correct? So from 9.5 until 10 half unit, then plus 1 unit. This is task 1. And task 2 half unit, which is from 11 until 11.5. So there is no missed deadline. Done. So now we find the response time of each aperiodic. Response time of aperiodic 1, complete time, A1 complete at 4.5, minus release time of A1
2.8.
2.8 minus 2.8 equal 1.7. Okay. Release time of A2 complete time at 9.5 minus release time of A2 5.5 equal to 4. So as you see here, the response time of A1 was 2.4 without slack stealing, and with slack stealing become 1.7, much better. For A2, the response time was 6 and become 4 with slack stealing. So the main important point here that we can repeat it at this unit A2, okay, A2 was supposed to be executed at this from here, okay, until 1, 2.5 until here, until 8.5, supposed to be executed here, A2. But since there will be missed deadline, T1 will exceed it deadline. If we execute A2 at this unit, T1 will exceed it deadline. Okay, so in this case, first we execute task 1 from the end, from 9 until 7.5, which is 1.5 unit. Then we can execute the ability of A2, that what we have that on the slack time, we can execute as much as we can from A2, and the remain will be to the next interval. Okay. Any question?